For section 4.5, we're going to go over writing an equation of a line thing is somewhat vague. And a lot of times it boils down to slope intercept, which is the previous lesson. Now, the 4.5 starts off with standard form of an equation. So what I have here is of the standard form of an equation. So we got plus by equals c. Now, this is a very abstract form of the equation. But one thing that we have to make clear is that A, B, and C, which just means like they're not decimals, they're not fractions or mixed numbers. They're like -8 or 7 or 2 or 0. You know, that's possible. 0 is an integer as well. But they can't be fractions, all right? So they all have to be integers. And I don't know if this is really totally applies to this, but so they have no common factors. A, B, and C, those values have no common factors. Think of it like a fraction. You know, like if you have a fraction like let's say you have like 5/10. Is that in lowest terms? No. 5 and 10 have a common factor of 5, so they can reduce to 1/2. So think of it like a fraction that hasn't been properly reduced all the way. That could be true. So if A, B, and C all have a common factor, like 2 or something, perhaps divide everything by that number so that you whittle it down to smaller numbers. And the standard form of an equation, you'll note as well that the x term and the b term, let me put this another way, the x term and the y term are on one side of the equation, and the c term is on the right side of the equation. So for this first example, rewrite each linear equation in standard form. So let's go ahead and get the x and the y on one side. So we're going to move this term over here. We're going to move the constant to the other side. And pardon me for not showing all the inverse operations here, but I'm going to just kind of move things around here. Now, and here's another important part about standard form. Let me go back up to this. Another thing, while I'm thinking of it, A must be positive, which is why this one made me think of that. This one, the coefficient of x is not positive. It's negative, obviously. So if we want to get rid of a negative, I mean, some people think, well, I'm just going to erase it. It doesn't always work out that easily. I mean, sometimes it seems that easy. But in order to get rid of a negative, all you have to do is divide everything by -1. You can factor out a -1. So then it becomes, when you fix it up, you get 5x plus 2y equals -11. Now, the constant, the c term is negative, but that's okay. What matters is that leading coefficient of x. You know, you get that term. That term is that better be positive. Okay, so now this is truly in standard form. All right, number 2, we basically have, just some fractions here. And if you've learned anything in this class, you know that we should clear out fractions. So let's do that first. Let's clear out fractions by multiplying everything by the LCD. And the LCD of 3 and 4 is going to be 12. So we're going to multiply everything by 12. Multiply 3/4 times 12, 1/3 times 12, and even y times 12. Everything, not just the fractions, but every single term, except what's in parentheses. This one doesn't have parentheses, but everything that you see in the problem gets multiplied by that LCD. This turns into 4, this turns into a 1, that turns into a 3. And let's go ahead and rewrite it. Now we've got 12y equals 4x minus 9. Okay, now in order for something to be in standard form, we just need the x and the y to be on the same side. Well, right now, as of right now, the x is positive. So why don't we move the y term to that side? Let's do that. Let's move this term over here, and let's move the constant to the other side here. So when we do that, we get 9 equals 4x minus 12y. And if we want to pretty it up even more, we can just kind of flip things around. And now that's in standard form. The x term is positive. The a, b, and c are all integers. There's no fractions like we started off with. And there's no common factors. Although 4 and 12 are both divisible by 4. 12 and 9 are divisible by 3. But there isn't one number that divides into 4, 12, and 9. Okay, for this next one, it says, write an equation of a line with a given slope and y-intercept. Express your answer in the indicated form. So for this one, we have the slope, we have the y-intercept. So it's just a matter of putting it into y equals mx plus b form. This is really just a matter of just plopping those numbers where they belong. So it's going to be y equals, and so our slope is -7. So we got negative 7x, and our y-intercept is 4. So we're going to do negative 7x plus, and that's all you have to do for number 3, because our main objective for this problem was just to get it in slope-intercept form. All right, for number 4, it's asking us to get it into standard form. So let's go ahead and put it in slope-intercept form, because that seems to be all the information that we have. So let's do that. So we've got y equals 6x plus 2, all right? And in order to get it into standard form, we got to get the y and the x on the same side. So I'm gonna move this y over here since this x is already positive. I'm gonna move the constant to the other side of the equation, and you should get 2 equals 6x minus, and it's just 6x minus y equals 2. And that one does not have any common factors. The coefficient of the x term, that's our a, is positive, and that's what we want. All right, steps for using point slope formula to write an equation of a line given its slope and a point of a line. So point slope formula is a little bit of a mouthful. Let's go ahead and jot this down. It's y minus y sub 1 equals m times, and then parentheses, x minus x sub 1. Jot that down, and let's kind of talk about all these things. So right here, you've got your slope. Right there, your slope goes there. Slope goes there, and your y term, right? I should say y coordinate, and your x coordinate go right there. These values right here, this x and this y, you leave them alone. Let them be. You don't want to get rid of them. You don't want to substitute values in there. Okay. Now the point slope form, that whole thing that we wrote down, point slope form isn't necessarily like the greatest form of an equation. However, it's a great place to start, given a limited amount of information about the graph, the line on the coordinate plane. So it's a great place to start. And then if we simplify that equation into perhaps like slope-intercept form or standard form, it becomes a little bit more clear. So on this one, all we're given is a slope and a point. So that's what we're going to do. So we're going to put those values in. I'm just going to rewrite it again. What I'm going to do, and we're going to put for this 2, that 2 is going to go right there. And for this 5, that 5 is going to be implanted right there. And 3/5, that is your slope. That's going to be put there. All right, so a lot of things basically just have to kind of be dropped into those spots. And then let's drop those there, and then let's simplify it next. Let's just take one thing at a time. So we got y minus y sub 1, that's going to be 5, equals, and our slope is 3/5 times, and then parentheses, x minus, and our x sub 1 is, okay, so now at this point, everything is where it needs to be. Our slope is 3/5. We've got our y coordinate, we've got our x coordinate where they need to be, and now let's just break it down and get the y by itself, because that's what we want to do. We want to get it into slope-intercept form. So we're going to, let's go ahead and clear the fraction. Let's do that by multiplying everything by 5. Everything gets multiplied by 5 except for what's in parentheses. When you do that, you get 5y minus 5 equals 3, and then x minus 2. Because these right here, these cancel. Okay, so now we don't have to deal with adding or subtracting fractions. We might get a fraction at the end. That's definitely possible, but we don't have to deal with the adding or subtracting of the fractions. So now let's clear the parentheses by distributing. So you get 5y minus 5 equals 3 times x is 3x, and then 3 times 2, which is 6. All right, now our goal is to get y by itself. So let's move the 5 over. Let's add 5 to both sides. Add 5 to both sides. So now we've got 5y equals 3x minus 1. We just did negative 6 plus 5 is negative 1. And now it's just a matter of dividing everything by 5. And so when we're done with that, we get y equals 3/5 x minus 1/5. That's not the prettiest looking answer, but it's the way we want it to be, because it said put it into slope-intercept form. All right, for number 6, we want to put it in standard form. Do standard form. So a good starting point is point slope. Point slope, I'll write it down again. It doesn't hurt to do that. Point slope is y minus y sub 1 equals slope times x minus x sub 1. Go ahead and put those values in. So y minus 5 equals, our m is negative 3, x minus, okay, so we went from point slope and put all the parts that we need. Remember, whenever you do this, we leave these values alone. Don't touch them. We want to maintain an x and a y in the equation. And let's go ahead and simplify this. So we've got, I'm going to clear the parentheses by distributing negative 3. So negative 3 times x, negative 3 times negative 2. So that makes negative 3x plus 6. All right, and now let's get the 5 over to the other side. These cancel each other out. And now we have y equals negative 3x plus 11. Now you'll note that now it's in slope-intercept form, but that's not what we want. We want standard form. Standard form is where the x and the y are on the same side, the constant's opposite on the opposite side, and the x is positive. So we have one more thing to do here, which is to take this and bring it over here. So we're going to bring negative 3x over, and it becomes positive 3x. So 3x plus 1y equals 11 plus y. 3x plus y, or 1y, equals 11. So now that's in proper standard form right there. All right, next part here. Steps for using point slope formula to write an equation of a line given 2 points on the line. Now, when you're given 2 points, that's enough information to tell you what the slope is. So that's the first thing you're going to want to do, is find the slope, because slope is a very important part of whatever form we want to put it in. So we want to find the slope. So let's do 1 minus 7. That's the difference of the y's. 1 minus 7, and then 2 minus negative 5. That's the difference of the x's. 1 minus 7 doesn't really simplify. The bottom becomes 2 plus 5. 1 minus 7 is negative 6. 2 plus 5 is 7. So there's the slope that we're going to use. So the slope is negative 6/7. Okay, now this problem is asking us to put it in slope-intercept form. Slope-intercept form. Now, neither one of these points right here, this nor this, are intercepts. Those are just points on the coordinate plane. If they were intercepts, you'd have a 0 for the x in one of them, and we don't have that. So let's start off with point slope. So point slope we're going to do. I always write it down, just doesn't hurt to do that. And let's put some values in here. So now when it comes to point slope, you just have to pick one of the points. It doesn't matter which one you use. I'm going to use 2, 1, because both of those are positive. All right, so we're going to do y minus, and I'm going to use 2, 1, so I'm going to use 1. So y minus 1 equals negative 6/7 was our slope that we determined, times x minus, and our first x is 2. Okay, so now we got all that. And what I want to do next is clear the fraction. I clear that fraction by multiplying everything by 7. Everything gets multiplied by 7 except for what's in parentheses. And 7 times y is 7y. 7 times 1 is 7. And right here, these 7's cancel. That was the purpose of clearing the fraction, because we want to get rid of that denominator. So we got negative 6, and then leave the parentheses, what's inside the parentheses, alone. All right, now we want to put this in slope-intercept form, so we want to get y by itself. So we've got to clear those parentheses out. Let's do that. Multiply by negative 6. Okay, negative 6x plus 12. All right, and then we're getting closer to getting y by itself. So now I'm going to do the inverse of minus 7 by adding 7 to both sides. Rewrite it again. So we got 7y equals negative 6x plus 19. And now it's just one more step, which is divide everything by 7. Divide by 7. Divide by 7. Divide by 7. Everything gets divided by 7. Kind of A weird looking answer again, but it's right. So y equals negative 6/7 x plus 19/7. That would be kind of hard to graph because 19/7 would be, you'd be purely guessing as to where that is on a normal graph. It would be kind of tough to put it in. But the point for this problem was just to get it into this form, which is what we did. It's in slope-intercept form. We've got the slope, negative 6/7, and we got the intercept, which is 2 and 5/7, right? 2 and 5, so it's somewhere between 2 and 3. But 19/7 is fine. All right, standard form. All right, so for standard form here, we're going to go ahead. We need to find the slope. So let's do that. So for slope, we're going to do subtract the y's, 7 minus 3, subtract the x's, 4 minus 2. 7 minus 3 is 4, 4 minus 2 is 2, and that comes out to 2. So there's your slope. Slope equals 2. And now I'm going to go to the point slope formula, and just pick whatever one. I'm going to use 2, 3 here. Both of them are positive, so they're both just as easy to use with whichever one you pick. And let's go ahead and put those values in. So we got y minus, all right, we've got 3 equals, our slope was determined to be 2 times x minus, and our x1 is 2. And let's get those parentheses cleared out. So you got y minus 3 multiplied by 2. So you got 2x minus 4. And let's since the 2x is positive, because we want to get this in standard form. Standard form is where you have ax plus by equals c, and the a has to be positive. So right now the x is positive, so let's leave it that way. So let's add 4 to both sides and rewrite it. So now we've got y plus 1 equals 2x. Negative 3 plus 4 is 1. And then let's go ahead and subtract y from both sides. And nothing really happens other than the fact that that y moves over and it changes its sign. And now we have it. We have 1 equals 2x minus y, or 2x minus y equals 1. They are both exactly the same. It's just a little prettier when you write it like that because that's the kind of the format of standard form. And that's exactly how we want it. 2 is an integer. The integer of this one is negative 1, and the number 1 is an integer. Now the steps for writing horizontal and vertical lines has been discussed in previous lessons, but just so you know, so when it's y equals some value, that is going to be that's going to be a horizontal line. When there's no x in it, it's just y equals 2, y equals negative 5, y equals 1/2. So if it's just like one of those, it's just going to be perfectly horizontal. When it's a plain old x equation, x equals some value, x equals 0, x equals 2, x equals 5.8. That is going to be up and down. That's going to be vertical. Now, a horizontal line, when you guys are graphing that, when you graph a horizontal line, it's good to note that the it's perfectly straight. But when it's horizontal, so when it's horizontal, okay. Now for number 9, we've got a horizontal line containing the point negative 511. Now you don't have to graph this, but I'm going to make just a rough sketch of where negative 511 is. So negative 5 right here. All right, so I'm running out of room. Negative 511. So if we were to draw a bunch of points on this, you're going to note that what number doesn't change? Well, what doesn't change is the y. The y is going to stay 11. So this could be negative 111. This could be 111. This could be 211, 311, etc. But notice the 11 is always the same. All right, so when we write this out as an equation, it's just going to be y equals 11. That's it. Now, line with undefined slope. Undefined is just another way of saying it's vertical. It's a vertical line, goes straight up and down. So it doesn't hurt to do this either. But you've got 6, -8. That is going to be right there, approximately. It's not perfect. And then a vertical line is going to look like that. So the coordinates of this point is going to be 6, -8. Coordinates of this one is, 6. I'm just making it 6, -7. Right here, this could be 6, -1. Right here, this could be 6, +1. This right here could be 6, 3. But notice, every time I wrote the coordinates there, what didn't change? The x didn't change. The x was always 6. And so the equation for this one is going to be x equals 6. Now, you don't have to do that every time. I mean, once you understand the idea here, most people just look at the coordinates and they're like, oh, the y is 11? That's y equals 11. Right here, same thing. They'll look at the coordinates 6, -8, and they notice the 6 is the x, so it's got to be x equals 6. You don't have to draw it out. I was just drawing it out just so you can kind of see, why it is the way it is. Steps for writing an equation of a line that is parallel or perpendicular to a given line. My advice would be to always start with, I would say like 99 times out of 100, you want to always start with that point slope form, which is this. And then simplify from there. That's a great starting point right there. All right, so the first example for this part, for problem 11, write an equation of a line meeting the given conditions and then express the answer in the indicated form. So we've got a point 4, -2, and it's parallel to the line 3/4 x plus 9. Okay. Now let me focus in on this part right here. Now this right here is important because that equation right there, that equation tells us what the slope is. It tells us that the slope is going to be 3/4. And since we're doing something that's parallel, we want to use the same slope. So we've got our point right here. We've got our point, and we know that our slope is 3 to 4, 3/4. All right, so let's start with that slope intercept, or that point slope form. We're going to do y minus, and then the y is -2 equals, and then we're going to put 3/4 in there. Put 3/4 x minus, and our first x is 4. Okay, now on this one I'm not going to bother with clearing the fractions because I noticed that when I distribute, when we distribute the 3/4 times x, we get 3/4 x, and then 3/4 times 4, that will in turn clear that fraction out. All right, and by the way, we want to get this in slope-intercept form because we want to get it in this form where it's y equals mx plus b. The y is positive and the y is by itself. So I'm going to clean up this part. I'm going to write y plus 2. I'm going to distribute 3/4 times x, so that becomes 3/4 x. And then 3/4 times 4, the 4's cancel, and so you get -3. Now it's almost in slope-intercept form. All we have to do is move that 2. So subtract 2 from both sides. And you get y equals 3/4 x, 3/4 x minus 5. And that's all we have to do. And that's going to be parallel to that original equation. Notice they have the same slope and they have different y-intercepts. One of them has an intercept of 9 and the other one has a y-intercept of -5. All right, so for number 12, we want to use the 0.52 and we want it to be parallel to that equation. Now the equation that it is in right now is like not anything, I mean, nothing specific. It almost looks like it's in standard form, but not quite. So let's get it in slope intercept form. Let's get the y by itself. And to get the y by, this is really easy. Just move that 2x over. So it becomes y equals 2x plus 6. So that's all I did. Let's move over that term. All right. Now doing that, the important part of doing that was it told us the slope. The slope is 2. And that's the important information. It's 2 or 2 over 1. You don't have to write 2 over 1, but it's just 2. All right. And for this one, we're doing it in standard form. So guess what? We're going to start with point slope again. Start with this form. And we're going to put in the values that we know. So we're going to do y minus, our y sub 1 is 2, equals, and our slope is 2 times x minus 5. And we want to put this in standard form. So let's clear the parentheses no matter what by distributing. 2 times x is 2x. 2 times 5 is 10, so minus 10. And I notice that the x is positive, so let's move the y over to this side, and let's move the constant over to this side. So sorry I'm not showing all the inverse operations here, but I'm just going to show you what things change into. So minus 10 turned into positive 10, minus 2, equals 2x. And this is positive y, so when it passed over the equal sign, it became minus y. Now we're almost there. 10 minus 2 is 8. 8 equals 2x minus y, or 2x minus y equals 8. See, there's your a. Your b is negative 1, and your c is 8. And all those numbers are integers, and the a is positive, and it's in standard form. Now for number 13, we're going to do perpendicular lines. So we want to do perpendicular. Now we know perpendicular has an opposite. They have opposite signs and they're reciprocal of each other. So for this one, we've got a slope of negative 1/3. Negative 1/3. So the opposite reciprocal of that is going to be, the reciprocal slope is going to be positive 3. I mean, it's really 3 over 1. You don't need to necessarily show that, but it's just 3. Because the opposite of negative is positive, and when you flip 1/3, it becomes 3. 3 over 1. All right, so now let's go ahead and start with that good old-fashioned point slope form. Do that, so we got y minus, and then we're going to do that one. Negative 1 equals, and we've determined our slope to be 3. Our perpendicular slope is 3 minus, and then our x sub 1 is negative 1. Now let's clean this up a little bit. We've got negatives next to each other, so let's go ahead and make those into positives. So you got y plus 1 equals 3, and then I'm going to write x plus 1 here. I didn't distribute anything. It's just kind of a good idea to simplify as much as you can before we start clearing parentheses. And so we're going to clear parentheses by distributing the 3. Y plus 1 equals 3x plus 3. And then what form are we getting this into? Slope-intercept form. So we want to get the y by itself. So to get the y by itself, we have one more step. We're going to subtract 1 from both sides, and that should do it. Y equals 3x plus 2. And we don't have to graph that. But if we did that on the coordinate plane, 3x plus 2, that would definitely be perpendicular to the original equation, negative 1/3 x plus 5. Where they cross would be perfect right angle, 90 degrees. And this one says we've got the point negative 5, negative 12, and we want it to be perpendicular to that equation. So that equation, as of right now, it is hard to kind of tell what the slope is because let's get it into slope-intercept form. Let's get the y by itself. So you got 2x plus 3y equals 12. And let's take away 2x from both sides. So you got 3y equals negative 2x plus 12, and then just divide by 3. Divide by 3, and then we get from that, we get y equals negative 2/3 x plus, and 12 divided by 3 is 4. Okay? So the purpose of doing all that was to figure out what the slope was. All right? Now we're looking for the perpendicular slope. So the slope is negative 2/3. So the perpendicular slope, that's the symbol for perpendicular, by the way, is going to be the reciprocal of that, which is 3/2, and the opposite. So it's negative, so it's going to be positive. So there you have it. So the perpendicular slope is going to be 3/2, 3/2. And we want to put this in standard form. But we're going to start off with point slope again. So y minus y sub 1 equals m times x minus x sub 1. Got y minus, and we've got negative 5, negative 12, but negative 12 there equals, and our slope was 3/2, 3/2, and then x minus, and this one was negative 5, right? Yeah, negative. Let's clear this, let's kind of simplify this up a little bit. Y plus 12 equals 3/2, and then x plus 5, like that. And let's clear that the parentheses there. It's kind of making some room there. It's kind of writing way too big. Let's clear the parentheses by multiplying everything by 2, because that will get rid of the denominator. So everything but what's in parentheses gets multiplied by 2. I'll rewrite it at this point. So you got 2y plus 24 equals, now these 2's cancel, 3, and then x plus 5. Now it's, let's distribute that 3. So now we got 2y plus 24 equals 3x plus 15. And let's move the y over here, because the x is already positive. And let's move the constant over here. Okay, so let's do that. So when we do that, we got 24 minus 15 equals 3x minus 2y. Then 24 minus 15 is 9. So 9 equals 3x minus 2y, or 3x minus 2y equals 9. And that's in perfect standard form right there. Okay, for number 15, we've got, since 2005, vehicle consumption of E85 fuel, ethanol, which is 85% corn, has increased by about 8,260.7 thousand gallons per year. In 2009, approximately 70,916.6 thousands of gallons were used. So write a linear equation to model this data. Let x represent the number of years after 2005, and let y represent the amount of E85 fuel in thousands of gallons consumed. So we're going to do, x is going to be the number of years after 2005. So in 2005 it's going to be 0, and we've got, what is it? It was 8,260.7, and the other one is the year 2009, which is 4 years after 2005. So you're going to put a 4 where the x is, and then we're going to use this number, 70,916.6. Okay. So now what we're going to do is we're going to put that into slope formula. We're going to do 70,916.6 minus 8260.7 over the difference of the x's, like that. All right, so when we do a little bit of the arithmetic there, 70,916.6 minus 8,260.7 is right here, 62,655.9 over 4. And now I wouldn't bother trying to change that into like fraction. Let's just go ahead and divide. I'm going to use my calculator and just divide that by 4. And this is what I get. I get 15,663.975. Okay, so that's our slope. I'm going to write that up here because I'm running out of room. And now let's get it into, now this one's asking us to write a linear equation. I would just get it into this. Let's get it into slope-intercept form. We're going to do y minus, do this, y sub 1 equals the slope times x minus x of 1, which is 0. You can see why I used that, because when we multiply by 0, it's just 0. Okay, now if you look at those two, ordered pairs, this particular ordered pair right here is particularly useful because that is our y-intercept. That's our y-intercept because we have an x is 0. And so now it's just a matter of plopping it into the y equals mx plus b. So we know that our slope is 15,663.975. Then we're going to put x, and then plus the y-intercept, and that's it. That's all you got to do for that one. All right, and how much E85 fuel did the vehicles use in 2005 and in 2007? Well, 2005 is, is 0 years after 2005. So when we put that in, when we evaluate that, we're going to put a 0 right here. And anything times 0 is just going to be 0. So you got 0 plus 8,260.7, which is equal to 8,260.7. I think it's 8,260.7 thousand gallons, but we've got it. We got the number that we need. And then for 2007, that's 2 years past 2005. So we're going to do slope and multiply that by 2. And there we have it, 39,588.65 thousand gallons. So that's a lot. That's a lot of corn. Okay, we ran out of notes. Okay, that does it for this section. See you later.